So we're going to start talking about velocity time graphs this week. Okay, so we've now covered speed, distance, time, velocity, vectors and scalars. Last week we covered acceleration, and so this week we're going to move on and start looking at how these things can apply to the motion of objects. Okay, and so we have three speed time graphs that are going to be particularly important, velocity time graphs that are going to be particularly important to us. We're going to have a look at them here. So what we've got is our first graph here, which we've got velocity on the y-axis and time along the x-axis. And as you can see from the straight line there, the velocity of the object doesn't change over time. So this graph represents a constant velocity. Okay. Now, the second graph shows us an increasing velocity over time, but it's a straight line, so it represents a constant acceleration because the velocity is constantly increasing to give us a straight line. And then in this last one here, the gradient of the line is negative, and so when we have a negative acceleration, that's a deceleration, so we have a constant deceleration. Okay. Using these graphs we can work out what's going on with a multitude of different objects as they're moving, okay, because from this graph if you can extract the starting speed and the end speed and the amount of time it takes to get somewhere, you can work out the acceleration of the object in that time. Okay, and so what that shows is the gradient of a speed time graph or a velocity time graph shows you the acceleration of the object. Okay. And the other thing we can do, so let me write that down, sorry. So the gradient shows acceleration. Okay, and the other key point is that the area under the graph gives us the displacement. Okay, those are our two key things we can work out from these graphs. So while these graphs show motion, so constant velocity, constant acceleration, constant deceleration, they also are able to allow us to work out these other things, the acceleration and the displacement of the object. So from a velocity time graph you can get quite a lot. We're going to do a couple of examples of acceleration calculations and then an example of displacement calculation so you can see how it works. And then again there's another worksheet for some practice. Okay, so calculating acceleration. So we've got a velocity time graph here where it says the object is going from 0 up to 12 in 6 seconds. So the first thing we have to do is extract our numbers. So same as when you're doing acceleration questions, write down what you know. So v being our final velocity, it's going to reach 12 meters per second according to the graph. U is 0 because it started from the 0 point on the axis. The acceleration is what we're trying to work out, and the time it does that in is 6 seconds. So our equation is A equals V minus U over T, which is going to be equal to 12, take away 0, divided by 6, which is 2 meters per second squared. Okay, our second one here, we've got an object that's started at 19 meters per second and then decelerated down to 10 meters per second in 3 seconds. So again, write down what you know first. So our final speed here is 10 meters per second. Our initial speed is 19 meters per second. Acceleration is what we're trying to work out, and the time is 3 seconds. So acceleration is v take away u over t, and so we're going to have 10 take away 19 over 3, which is going to be minus 9 over 3, which is going to be minus 3 meters per second squared. Okay, now remember the minus represents the deceleration. Okay, and so those are fairly straightforward. We're using the same calculations we used last week, only this time we're using it by extracting our values from the graph. Okay, and then to calculate the magnitude of the displacement. Okay, now really important, the area under the graph equals displacement. Okay, I'm going to circle that because that's super important. It's going to become very useful for us over the time that we're doing physics, so it's something you need to 100% remember. Okay, now when you look at this graph that I've got here, I've separated it all out and I've marked on all our different times, so all the numbers we need are there. But what we need to do is look at how we're breaking it up. Okay, and so get a wee highlighter. We've got one shape here, which is a triangle. Okay, and we can work out the area of that triangle. We've then got a square, big square, rectangle more like. So we can work out that all as one. Okay. Then we've got another triangle here, which is on top of a square. And I'm going to run out of colours to highlight with, but it's on top of a square there, or a rectangle. Okay. And then there's a final rectangle, square, rectangle there. Okay. And so we have 1, 2, 3, 4, 5 shapes that we need to calculate the area of. And then when you add all those shapes together, that gives you the total displacement of the object. Now, working out area of a triangle is a half times base times height, and the area of a square or rectangle is just base times height. Okay, so area 1 is a triangle, so it's going to be a half times base times height, which is going to be a half times 7 times 20. Okay, and so that's going to be 70. Area 2 is just a rectangle, so it's base times height. Its base goes from 7 to 14, so it's still 7 because it's only from the 7 to the 14 for the base, and it goes up to 20, so it's 7 times 20, which is 140 metres. Area 3 is a smaller triangle. It goes from 10 to 20 and goes from 14 to 18. So if it's a half, if it's a half times base times height, it's going to be a half times 4 times 10, okay, which is going to come out at 20 metres. Area 4 is base times height because it's a rectangle. So base times height is going to be 4 times 10, which is 40. And area 5 is base times height, which is 2, because 18 to 20 is 2, times the height of 10, so that's 20. And then for your final answer for the displacement, you add all of those together. So 140 plus 70 is 210, plus 20 is 230, plus 20 is 250, plus 40 is 290 metres. That's our final displacement. Okay. Now, there'll be a worksheet to give you some practice of this, calculating the acceleration or the displacement. Good luck.